Hi there and welcome to Mr. T's Maths. In this video, I'll be showing you how to find coordinates of stationary points and classify them. First of all, let's see what are stationary points. Well, stationary points or turning points are these points where a curve has the gradient equal to 0. In other words, where dy dx equals 0. Now, we can classify stationary points as maximum or a minimum. A stationary point is a maximum when the gradient is decreasing from positive through to 0 and then to negative. Similarly, a stationary point is a minimum when the gradient is increasing from negative through to 0 and then to positive. It's important to know, to recognize these type of curves, quadratic curves and cubic curves, because these can help you classify stationary points. Now remember that quadratic curves are in the form y equals ax squared plus bx plus c. The important part here is the coefficient of x squared, a. Well, when a is positive, then we end up with a U-shaped curve, and therefore we will know that the stationary point is a minimum. Whereas when a is negative, the stationary point is a maximum. Now cubic curves are of the form y equals ax cubed plus bx squared plus cx plus d. Similarly to quadratic curves, a, the coefficient of x cubed, is important here and determines the type of graph this equation will produce. The first graph is for a greater than 0, and I would like to point out that let's assume I'm going to draw here the axis. Let's assume that this is plotted, that's y, and this is your x. Okay, once you find your stationary points, if your graph looks like this, then the point with the x coordinate, let's assume that has x coordinate x1, and this point has x coordinate x2. Now the point with the x coordinate, the smaller x coordinate, in this case will be a maximum point. How do we know this is smaller? Because it's closer to 0, or it's to the left hand side of x2. And the point that has the x coordinate greater will be, in this case, the minimum point. So by inspection we can actually classify the stationary points. Yeah. If a is less than 0, then this kind of graph is produced, and therefore if I draw my axis, let's assume this is plotted, then we end up with an x1 coordinate for one of the points and x2 being the x coordinate for the second point, let's say, where in this case the point with the smaller x coordinate will be classified as a minimum point, and the point with the greater x coordinate will be classified as a maximum. Okay, let's move on and have a go at an example. Find the turning points of the curve y equals 2x cubed minus 3x squared minus 12x plus 1. Now first of all, just have a look at this function and determine a. A here is 2, which is greater than 0. Therefore, this will produce a cubic graph like that. So we are expecting to have a maximum point and a minimum point. Right. How are we going to do this? Well, we've just learned that at the stationary points the gradient is 0. So therefore dy dx has to be equal to 0. Now what is dy dx? Well, let's differentiate the function to find out. Dy dx equals to, remember, multiply by the power and subtract 1 from the power. So 3 times 2, 6x squared minus 6x minus 12. Okay, and we form a quadratic equation. 6x squared minus 6x minus 12, we know it has to be equal to 0. So now let's find those values of x for which this is equal to 0. What I would do is divide everything by 6 to simplify this equation. So x squared minus x minus 2 equals 0. Now we have to factorize. Okay, minus 2, we have to find two numbers that multiplied together give us minus 2, and when added is minus 1. These are minus 2 and 1. Okay, so now we have to ask ourselves, when will the product of two numbers be equal to 0? When these, either one of them equals to 0. Okay, so that's why we end up with x minus 2 equals 0 or x plus 1 equals 0. So x has to be 2, and x in this case is minus 1. Okay, these are the two points. Now we want to find the coordinates of these stationary points. So if we substitute x equals 2 and x equals minus 1 in this equation, yeah, you will find the y coordinates. So let's quickly do that. So when x equals 2, then y equals 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 1, and that is going to be equal to minus 19. Hopefully you found that. Okay, so we have one point is 2 and minus 19, and the second point is when x equals minus 1. Okay, I'm not going to substitute here. You should know how to substitute already in an equation, so you do that. Be careful with the negative signs, yeah, with the negative there when you put it in your calculator. So y should give you 8, right? So we have the point 2 minus 19 and minus 1, 8. Okay, now by inspection, yeah, since we know this is the graph it produces, okay, then we can assume since a is greater than 0, okay, the number with the smaller, the point with the smallest x coordinate, which is in this case minus 1, will be this point here. So it will be the maximum point, yeah. So by inspection, okay, minus 1, 8 is the maximum, and 2 minus 19 is the minimum. Okay, I'd like though to show you another method of finding, of classifying the stationary points, and this is by looking at the local gradient. It's by looking at the gradient close to your stationary points. So our stationary points were minus, that's the curve, yeah, and we had a minus 1 and 8, okay, and we had the other point was 2 minus 19. Okay, so to classify these, we can actually have a look at the gradient of these points locally, right? So around the stationary point, just before and then after that stationary point. So we know that when x just draw a table. Okay, we already know that when x is -1, then dy dx, the gradient, okay, dy dx is 0. All right, so if we take a value just before -1, so -1.1, let's say, if we actually substitute this in the function for dy dx, we will find that the answer will be positive. Okay, then if we take a point just after -1, to the right of -1, which is -0.9, for example, then we will find that the gradient is negative. Therefore, as you can see, we are going from positive gradient all the way to 0. We reach 0, and then the gradient end up being negative. Okay, so this forms this kind of curve, so it should remind you of a maximum. Yeah, so therefore this is a maximum. Okay, now similarly we draw a table for the second point, 2 minus 19. All right, we already know that when x equals 2, the gradient dy dx is 0, right? So we take a point just before 2, let's say 1.9. Okay, you can take 1.5, 1 if you wish, but it's better to take it as close as possible. Then the gradient, if you actually substitute this in dy dx, I'll remind you that dy dx, the function dy dx, yeah, the gradient function was 6x squared minus 6x minus 12. So if you plug this 1.9 in here, you should find that dy dx is negative. Okay, and just after this stationary point, if we take 2.1, okay, we will find that the gradient is positive. Therefore, if we try to sketch the curve, it's a negative gradient, 0 gradient, and then a positive gradient. So we can see that it's this U shape. Therefore, this is a minimum. So this is a minimum. Okay, and that's it. We have learned how to find stationary points, yeah, by letting dy dx equal 0 and finding x, and then we have learned how to classify these stationary points by looking at by inspection, looking at the graph, okay, and a second method by looking at the gradient close to these stationary points on either side of the stationary points. Okay, I hope you found this video useful. If you haven't done so, please don't forget to subscribe and leave a comment with any suggestions. If you want other videos, do let me know. Okay, take care. Bye bye.